Hi, this is a presentation for submission number 5106 entitled Making Math Move. The motivation behind this work is twofold. The first part being the poor math performance in America with an emphasis on algebra and African American students. Algebra, which is the gatekeeper for courses and careers in STEM, is not being performed proficiently by students nationwide. Research suggests this is due in part to a weak foundation in the shift from arithmetic to algebraic thinking. For African Americans, in particular, as seen here, they are underperforming at math and all tested grade levels as reported by the National Assessment of Educational Progress. The second related motivational aspect behind this work is one of the reasons research attributes to the less than stellar academic performance by African American students, and this is the disconnect between cultures in the academic and home environments. To address these low proficiency levels for African American students in particular, the approach was to design and develop a culturally relevant educational technology that focuses on pre-algebraic areas deemed crucial for success in Algebra 1. There are 5 interdisciplinary areas that were used to create such a technology. The first being African American cultural ethos, which are 9 interrelated dimensions of African American culture. This system focuses specifically on movement and verb. The second, culturally relevant pedagogy, theorizes that the inclusion of cultural references in educational material can have positive effects on students. The final 3 are essential algebraic content, digital game-based learning to help engage students, as well as taking into account interface design guidelines. The combination of these components resulted in Makin Math Move, the gestural-based technology in which students perform gestures mapped to math operations used as they solve math problems. So how was it built? Makin Math Move is a Unity-based system. It can be accessed via an executable application. Unity was selected as the development environment due to its support of the Connect for Windows SDK. In addition to Unity and the Connect, programming was completed in PHP and C#. The Connect sensor is a gesture detection device which reads the gestures performed by students. As students perform the gestures, there is a special database that is analyzing such gestures and was created using the Connect's Software Development Kit's 2 applications, the Connect Studio and Visual Gesture Builder, or VGB. The Studio allows for the recording of the gestures, while the VGB, as shown here, allows for the training of the gestures. In order to train each gesture in the VGB, an individual database was created where the clips pertaining to that specific gesture were trained and compiled. Each of the individual databases were combined to form one large database, which was utilized by the Unity application. Within each individual database, I had to go through each clip and indicate where the gesture began and ended if it was a stationary pose, or where the gesture was fully completed and the progress leading up to that gesture if it was a continuous gesture. For gestures that may have been mistakenly identified with another gesture, for example, a gesture with only a horizontal left arm and one with both arms held horizontally, it was important to train the anti-gesture as false. As mentioned previously, the system was developed using the Unity game engine. This component is the center of the entire architecture and works with various other components to execute the problem-solving functionality by receiving and sharing information with the 3 databases, the gesture database, and the content and player's profile as seen below, and also displaying information to the user. The content database houses all of the problems utilized within the system and communicates with both the game engine in order to relay what information is to be used, as well as the player's profile database to update the status of the student's success. The player's profile database consists of not only the student's settings customization, but also tracks their progress. It will keep a record of their time spent on each question, the hints used, as well as the status for each problem, i.e. correct or incorrect. The final component, the audio/visual interface, refers to the method of displaying the technology to students and is inclusive of all visual and audio components, which is inclusive of the avatar and the problems, as well as the instrumental hip-hop music. The avatars, which you will see in the demo, were created using the Adobe Fuse software. Here, avatars were customizable across various features such as race, eye color, clothing, and even minute details such as the level of excitement and anger. Avatar models were then uploaded to Adobe's Mixamo software to have components included to allow for the rigging mechanisms necessary to mimic students' gestures visually in Unity. So here's the Makin Math Move home screen. And so students are able to select Go with their right hand, which tracks the cursor. Now at the setting page, students are able to pick their background and their music, and they can use the arrows to scroll through each category. They can preview the music by hovering over it with their hand, which acts as a cursor. On the next page, students are able to select their avatars, which were created in Fuse, and these avatars are representative of both male and female, and the students are able to select which one they would like to represent them on screen during Makin Math Move. As we begin, there are 3 different modes: Dress Rehearsal, Run Through, and Showtime. Students select Run Through, which helps them with guided practice to solve the problems. They begin by selecting their first number 12, and then tries to perform an operation. They tried a multiplication, did not work, so the hint said, let's try another operation. So they selected 12, do the gesture for subtraction, which is needed to solve this problem, and then they're able to subtract this with the 3. Once they are selected the right operation, they can choose the answer. It's incorrect, so they decided to delete, and then the 0 is still in the way, so they once again select 9, they press enter, and then the problem is complete. Student will have the option to move on to the next problem or end their session.